Okay, so if you had Team A versus Team B, how many possible outcomes? Well, either Team A would win or Team B would win. So if there's two teams, there would be one game, and then there would be two possible outcomes. Okay, and then as we come up with these numbers, we'll just fill them in the chart, and then we can look at patterns with the numbers. Okay, so it says how many different outcomes are possible if you have four teams playing, so that would be two games. So you'd have A versus B, and then C versus D. So when we figure out the outcomes, like either A or B would win here, so let's say A wins, and then C wins. And then maybe A and D, that's another possible outcome. Or B and C, or B and D. So in this case, there was 1, 2, 3, 4 outcomes. 4 possible outcomes. So you'd put a 4 here. So 2 games, 4 outcomes. Okay. Then how many different outcomes are possible with 6 different teams, 3 games? So 6 teams, 3 games. A versus B, C versus D, and E versus F. Okay, when I list these out, I'm just going to be changing like one letter at a time until I get all the combinations. So let's say A, C, and E. And then another possible combination would be A, C, F. And then I'm going to change D, E, A, D, F. And then for B, C, E, B, C, F. So there's all the possible combinations there. 1, 2, 3, 4, 5, 6, 7, 8. 8 possible outcomes. So 3 games, there was 8 possible outcomes. Is anybody seeing a pattern yet?
Exponential increase. It doubles.
Yeah. But 3 doesn't double.
Yeah, like it times 2.
You're getting there with the times 2. Okay. So then for this one, they want to look at how many games would have been played if there were 8 teams. So they want a relationship between the number of teams and the number of games. So they have like a tournament set up here. They're saying that 8 teams played, how many games? Well, let's say this is team A and B, C and D, E, F, G, H. So this would be 1, 2, 3, 4 games so far. And then just hypothetically, if A wins here and C wins here, and then E and G, then they would play. So that would be game 5 and game 6. And then if there's a winner, A and E, they would play, and that is game 7. So in a sudden death tournament, if there's 8 teams, then there's 7 games. And then looking at the table over here, again, we're just looking for patterns, and on the next page, we're going to tie together those patterns and look at what they actually mean. So teams playing in that round. So round 1, there was 8 teams, 4 games. Next round, there was 4 teams and 2 games. And then the final round, there was 2 teams and 1 game. Okay. Now on the next side, or for me, I'm going to flip the page. Flip it. Okay, so how many outcomes are possible with picking 8 teams, and there are 4 games now. So on your page, we're going to set up the 4 games. A versus B, C versus D, E versus F, and then G versus H. Okay, so I'm going to start listing combinations. I'll use a different color. Okay, so A, C, E, G, and I'm just going to change one letter each time until I get everything. Does my pattern make sense so far? Let's see. And then
Do we not need to worry about going into 6?
yeah, it's fine. Okay, so I listed out all the A possibilities. Now, if I were to start B, it would literally be the same combinations over here, but with B. So there are 8 combinations with A, and then there would be another 8 with B. So total, there would be 16 possible outcomes. So when there was 4 games, there were 16 possible outcomes. Does anybody see the pattern yet? Like, is there an equation we could use to figure that out? You're close. It does have to do with exponents. So for each game, like, there's 2 possible outcomes here. We can times that by 2 times 2 times 2. And that's how we could get the 16. So essentially, it's, if you were to set it up like an equation, you have a number here and then an exponent. This right here, the base, is number of outcomes per game. So in this case, 2. And then the exponent is the number of games. And then if you, I know some of you guys are writing. If you look back at the page before, so 4 games would be 16. And then this would hold true. So 2 possible outcomes raised to the first power would be 2. 2 possible outcomes raised to 2 games would be 4. 2 possible outcomes raised to the 3 would be 8. And 2 possible outcomes raised to 4 games would be 16. So there is your pattern right there. Okay, so once you've found a relationship between games played and total outcomes, you can find the total number of possible outcomes for a 64-team sudden death tournament. If you know the total number of games played in the tournament, use the graphic and the table below to help you determine this. What pattern do you see? Something we looked at before. So this assignment's all about like looking at smaller numbers and then applying it to bigger numbers. So when we had a bracket with 8 teams, there were 7 games. So in this, they're saying there's 64 teams. We can subtract 1 and get 63 games. So there's going to be 63 games played in the sudden death tournament. Okay, what patterns do you see? How does the total games played in the tournament relate to the teams playing? Does this relationship hold true?
When you do -1, what's that from?
So here, we saw that if we have 8 teams, we like drew it all out. We found that there were 7 games. So we're using that same pattern here. So if there's 64 teams, there would have to be 63 games. My other class had trouble with the concept with that one too. I actually like numbered it all just to like
It makes sense.
check it. It's cool.
Yeah.
Okay, but for some of you that might, so like I literally counted them all, and on this side there is 31 games, and then there would be 31 on the other plus the winning game. So that would make 62 plus the winning game, which would be 63. Makes sense. Okay. Now that you found the relationship between number of games played and the number of possible outcomes, use that relationship to find the number of possible outcomes in a 64-team tournament. The $1 billion bracket required you to pick from the field of 64, not the original. Reflect on your chances of picking that perfect bracket and winning $1 billion. Okay, so what we're going to do, actually there's more space here. Number of outcomes, so it would be 2 outcomes per game, and then there's 63 games. So if we did 2 raised to the 63rd power, we would get the chances of actually guessing all of these correct. And if you were to put this in a calculator, you would get a number. Oh, I have it already up there. 2 raised to the 63rd power gives you this number, 9.2 with all these digits raised to the 18th power. So that means you'd move this decimal over 18 times. So we are actually going to write this number on our paper. You could write it at the bottom. I'm going to write it on the side here and just literally write out all the digits so we can actually see how big it is. Okay, so here's the digits. 2, 2, 3, 3, 7, 2, 0, 4. And then move the decimal over 18 times. So 1, 2, 3, 4, 5, 6, 7, 8. I need 10 more zeros. 2, 3, 4, 5, 6, 7, 8, 9, 10.
Good Lord.
Yeah, it's a big one. Whoa. Okay, so how big is this number? So this is the odds of guessing every single game in the bracket. So when we fill this bracket out, some of the games have already been played, but if we were to guess every single game, the odds of guessing every single game would be 1 in this number. What is this number? It's quintillion. So the odds of guessing every game would be 1 in 9 quintillion. Okay. The odds of guessing the outcome of every match is 1 in 9.2 quintillion. Cool. So don't bet too much on that one.
That's gotta be worse than water.
Yeah, it's gotta be. Okay, we're not gonna do 9 and 10. What I'm going to do now is pass out the bracket. I printed this yesterday, and these teams hadn't played, but since yesterday, these teams played, and then these are the winners. So fill in the highlighted ones, and then guess the rest, and then after the tournament's over, we'll compare and see who guessed the most. Okay.